Prove that tan theta plus cotan theta identical to 2 cosec 2 theta. So we have tan theta plus cotangent theta identical to 2 cosec 2 theta. We can work with the left hand side or the right hand side, so you can choose which one you prefer. I'm going to work with the right hand side. Remember that 1 over sine theta equals cosec theta. Also remember that tan theta equals sine theta over cos theta. Also remember that 1 over tan theta equals cotangent theta. So those 3 points will be useful. Now I'm going to work with 2 cosec 2 theta, which can be written as 2 over sine 2 theta from this definition here. And I can then expand sine 2 theta. Well, sine 2 theta can be written as sine theta plus theta, which is sine theta cos theta plus sine theta cos theta, and that gives 2 sine theta cos theta. So that's what that is, where I could rewrite this as 2 over 2 sine theta cos theta, and 2 cancels 2, then I get 1 over sine theta cos theta. But also I'd like you to remember the fundamental identity that says sine squared theta plus cos squared theta equals 1. So I'm going to replace the 1 on top here with sine squared theta plus cos squared theta over sine theta cos theta. I'm also going to divide both numerator and denominator by cos squared theta. So that should give sine squared theta over cos squared theta plus cos squared theta over cos squared theta. So I'm dividing numerator by cos squared theta over sine theta cos theta over cos squared theta. So I'm dividing that by cos squared theta, and dividing that by cos squared theta. So that's what you're seeing here. And you can see the definition here, which is here. So that'll be tan squared theta, that's 1. Cos theta cancels cos theta, you're left with cos theta. Sine theta over cos theta will be tan theta. So now we can see the new tan squared theta plus 1 over tan theta, because that cancels each other, that's 1. 1 there, cancel 1 there, so you're just left with cos theta there. And sine theta over cos theta is tan theta. Now I need to rewrite that expression. So that would be tan squared theta over tan theta plus 1 over tan theta. So now we can see what would happen there. So tan squared theta, we cancel 1 tan theta in the denominator, so you're just left with, so you're just going to get tan theta. because that's a squared, tan theta squared, and the denominator is just tan theta. So one cancels the other, just left with 1 tan theta plus cotan theta, because you can see 1 over tan theta is cotangent theta. We've arrived with our proofs that tan theta plus cotan theta is identical to 2 cosec theta. Given that sine alpha is 5 over 13, find the value of alpha between 0 and 90 degrees. Pi over 2 is 90 degrees. Find the value of cos alpha and cos 2 alpha. So for cos alpha, first thing to do is to draw a right angle triangle. And this is the angle we're looking at. Let's call that B, and that's little b. Let's call that A, and that's little a. Let's call that C, that's a right angle, and that's little c. We can see the little b here is 5, because this angle for sine is opposite. So if we're using car to r. So for sine of the angle B is opposite over hypotenuse. The opposite is 5 and the hypotenuse is 13. If we use a Pythagoras theorem, we can find the side A. And the Pythagoras theorem says that 13 squared will be equal to 5 squared plus A squared. And 13 squared is 169 minus 25 equals A squared. And that's 144 equals A squared. Therefore, A equals 12. So this is 12. To find the cos, so for question A, cos alpha will be, and cos is adjacent over hypotenuse. The adjacent is 12. If this is alpha, so the adjacent will be 12, so that will be 12 over 13. And for B, we can find the cos 2 alpha is also written as cos alpha plus alpha, which is cos alpha minus sine alpha, and that is cos squared alpha minus sine squared alpha. And that can be written as, well, cos squared alpha, cos alpha is, we know what that is now, so that's 12 over 13, and if you square it, minus sine alpha is 5 over 13, and if you square it, you should get 144 over 169 minus 25 over 169, and that will give 119 over 169, and that is cos 2 alpha, and that's what we're looking for. Again, so that's the A part that we're looking for, that's the B part. Given also that 13 cos x plus alpha plus 5 sine x equals 6, find the value of x in the domain of 0 less than alpha less than pi over 2. Pi over 2 is 90 degrees. Okay, so we have 13 cos x plus alpha plus 5 sine x equals to 6. So we need to expand the cos x plus alpha, so that will be 13, open bracket, cos x cos alpha minus sine x sine alpha plus 5 sine x equals 6. Now, if I cos alpha, we know what that is because we just worked it out, so that will be 13, open bracket. Cos alpha is 12 over 13, cos x, minus sine alpha is 5 over 13, sine x, plus 5 sine x equals 6. If I multiply, open the square bracket, multiply everything by 13, so you get this. So I get 13 times 12 over 13 cos x minus 13 times 5 over 13 sine x plus 5 sine x equals to 6. So what do I get here is 13 counts to 13, 13 counts to 13, so I get 12 cos x minus 5 sine x plus 5 sine x equals 6. And therefore, the 5 sine x, we cancel 5 sine x, that will be 0. Then we get 12 cos x equals 6. Therefore, cos x equals 6 over 12, which equals a half. Therefore, divide both sides by cos, so I get x equals 1 over cos a half. And in indices, 1 over cos is cos to the power minus 1, so that will be cos to the power minus 1 a half. For x to be a half, cos, that's a recognizable angle, so that's 60 degrees. So x should be pi over 3. But we can plug into calculator what inverse cos a half is. If you want to put in radians, just do turn on the calculator, shift menu, 2 for angle unit and 2 for radians. Now you can do shift cos and then put fraction key button there, which is under option button key, and a half, 1, 2, arrow down and put 2 there, arrow to the right and close the bracket, so you get pi over 3. And you're only looking for the domain of 0 to pi over 2, so pi over 3 is the only answer we're looking for. Therefore, x equals pi over 3.